Hi again, my name is Gene. I'm a new mentor for high school robotics team FRC 714 from Newark, New Jersey. And today we're going to install very simple Python code on a big proper size robot provided by a competitor team, FRC 8630. I have it here sitting on my floor. Let's get started. First of all, if you have not downloaded PyCharm for editing Python code, now is the time. Punch download PyCharm into Google, click on the link, and you can download the professional version. Or for this specific project, we should be fine with the free version, also known as the Community Edition. So click download and don't look back. I already have it downloaded, so we'll proceed to the actual robot code. Link in the description. I already have the code on my GitHub, so what we will need to do is open PyCharm, which I already opened, and click the button Get from VCS, which in this case means Get from GitHub. Here in the URL, I'm going to punch the URL of the repository with the code and hit clone. Clone means download in Git. Once it is downloaded, most likely what will happen is we'll need to click on the lower right corner and pick which Python interpreter we want. I want Python 3.9. So I'm going to click Add New Interpreter, Add Local Interpreter, and I'm going to create a new virtual environment based on my base interpreter that I already downloaded before. If you have not downloaded it before, well, you could have downloaded it before. You can download later though, and you'll be offered options to download it right now. I'm going to hit OK, and my virtual environment is created. Next step is to go to the requirements file and make sure that all the requirements are installed. So we're going to be using robotpy package, which is the Python version of WPI-lib for all intents and purposes. And we will need to hit install all missing packages. Confirm, confirm. The package is installing. Now it can happen that for you, the pop-up with an option to install actually does not appear. What do? You go to terminal here on the left hand side of the screen, and you can just type pip install -r requirements.txt, which is the requirements file we have in here. Hit enter, and anything that's not installed yet will get installed. Let's take a look at what we have in terms of robot code in here. So what we need to do is we need to go to time-rep-tank, project name, robot.py, the only piece of Python code that we have in here. For some reason it is complaining that the Python interpreter is not happy, but I think I can happily ignore this. Most importantly, inside of the robot code, we have a method called robot_init, in which we initialize 4 motors that this robot has. Motor with CAN ID number 1, CAN ID number 2, CAN ID number 3, and CAN ID number 4. Because of how they are installed, left lead motor must be inverted, and also left follow motor must be inverted again from left lead motor. Right follow motor must also be inverted because they are all installed facing opposite from each other. which is fine. If your motors are installed differently, just make sure to say invert equals false for whichever ones you don't need inverted, and if you don't need to invert the left lead motor, then you don't need this line set inverted in here. I think we're prepared to sync. Sync means you download all the dependencies, all the dependent packages that are needed. I'm hitting sync, and I'm hitting run sync. Robot Pi is doing the magic of downloading all the dependent packages that we will need. Install complete. And now the error message about incorrect Python interpreter also went away. Everything is happy. We can edit the code, but most important function here is Teleoperated. As you can see in this function Teleoperated, we take the inputs from stick for joystick. Vertical input will be our Y speed, and horizontal input, which is axis number 0, will be our horizontal or turn speed for the arcade drive method of the robot drivetrain. So we take the X from horizontal axis of the joystick, Y from the vertical axis of the joystick, and then if the robot is teleoperated, which means this function teleoperiodic is going to be called 50 times per second, then the drivetrain will be asked to arcade drive with these two speeds. If you would like, you can first run this in simulation, in sim, just to see what happens. But we are actually ready to deploy this code to the robot by hitting the deploy button. First things first, the robot must be powered on. Now what we need to do is we need to connect to the robot over Wi-Fi. Or you can also do it with a printer cable. I'm sure you know how to do all of this, so I'm just connecting to the robot using Wi-Fi. And after we are connected, all we do is we hit deploy button here at the top of PyCharm. Run, deploy. And look what's happening. It takes a little bit of wait, apparently right now. First, it's asking me for the team number or robot host name, because it is not configured. Team number is 8630. Now it's going to connect to that robot and deploy successful. This code is deployed to the robot. Let's drive it. I have my green joystick here with me. I'm going to plug it in. Stop. We need to start the FRC driver station. Here we go, we have the driver station. The driver station shows that the battery is kind of low. Finally, the robot is teleoperated, is in teleop mode, and I can hit enable. Once the robot is enabled, I can move the joystick. And the robot is driving. Actually, without even turning the screen. In driver station, you can click on the joystick tab somewhere here to see if my joystick sticks have any effect. And they do, right? I'm barely touching the stick, the robot is moving. Now let's turn the camera. So today we deployed Python code on a big real-size FRC robot, and it was so simple. Thank you for watching.